Hello, a little bit of a different video from me today. I've been playing about with Arduinos and motors and things, and I've made this camera slider. And this is 1.5 meters long, the rail is, and it also has a pan and a tilt motorized section as well. The reason I wanted to make such a big one is all the ones that are sort of available seem to be just a few inches long, whereas this is about, well, it's 1.5 meters. I don't know what that is in English money. So basically what happens is you switch the device on and it'll automatically set itself up. The reason it has to do that is the Arduino needs to know where the motors are actually starting from, so it can set in 0 points for all the motors. And then what you should be able to do, hopefully, is set in 2 points, point A and point B. Now, everything's controllable on the potentiometers at the end there. There you go. Now it'll set up its pan. And then once it's done that and it levels up, it's ready to go. And the little light on the end turns blue. Now, you have full control of moving the thing around and panning, etc. So if I kind of face that towards you for the moment, this will be setting up position A. So let's say that's position A. And you'll press a little button and say the blue light changes to red. So the Arduino now knows that is position A. So then you set in a second position and maybe tilt the camera a little bit, or turn it a little bit towards the subject of what it is you want to film, like so. So let's turn it around that far. I'll make it do a good half turn. Okay, and maybe actually tilt the camera upwards a little bit. Now when I press that button again, the red light will turn to green, which means we're good to go, hopefully. There you go, turns to green. So now it's set in those 2 points. That's point A, this is point B. Now then, what the Arduino will do there is every time I press the button, it'll move everything from A to B. But depending on the speed of the whole thing, it'll move it so that everything, all the motors start and stop at the same time. So if you've only got a little bit of a turn, but a long sort of travel, then it'll meet up exactly where you originally set your A and B points, hopefully. So when I press this button, it's going to go back to there. It'll be facing this way towards me, and it's also tilting the camera back down again at the same time. So there's 3 kind of actions that's going off there. Now, it took me a bit of a while to figure out how to do all this. I've put the little end stop motors into the casing there and everything. Everything is controllable by speed, so that's stopped there. Now if I want it to go a little bit slower and take its time, I've got another potentiometer there that actually reduces the speed of everything. So from there to there, I can have the whole thing happen in 20 seconds, or I can have the whole thing happen in 20 minutes, depending on where I set this button. Now, once you set its extra positions and do a bit of a pan and a tilt and move it along like so, the red light turns green and says we're all good to go. And then every time you press it, this device is going to move from that A to B position. Now, what I've also done is if you press and hold this button, that will actually go back to blue, which means it's just cancelled out all its settings. Therefore, you don't have to keep switching it off and setting this up so that it comes back to the actual end stop switch here. So now you can just put in a whole new set of coordinates into there. Every time I press the button, it reads that potentiometer for the overall speed, calculates everything, and then starts off on its journey. So I can also, with these little switches here, I can also disable the actual motors, and that way it's only taking 1/10 of the power. So if I was running it on battery, I've made a little sort of connector under here so I can attach a battery and use it outside and that will switch off all the motors so it doesn't lose its two positions, its point A and its point B. So press the button again, and now it's going to do it slower because I've turned down the potentiometer on the end there. The USB is on the far end, so I can change a little bit of the coding and things as and when I please. All the wires actually run inside the rail, and they come out at the halfway point and through this sort of tractor device into the head. The wires go up through a shaft in the center of the head, so nothing really gets tangled up too badly. Kind of try and make it look a bit neater, even though it's homemade, as you can tell. Anyhow, I'm going to get along and make the video now. The video, obviously, this is actually the piece I filmed at the end of the video, but I'm putting it to the beginning of the video so you can see the steps that I've gone through to actually design and build this. And it's all been a bit of a guess as I've been going along, but I think it's turned out reasonably okay. All the Arduino coding will be on my website. All the links is down below there. And also motors, the rails, all the bits and pieces that you can possibly buy off Amazon. There's links to everything there as well, which I declare I've got an affiliate link with. So anything that you buy from there, I get a teeny little bit back. But anyhow, I hope you're going to watch the video. It's a good half an hour long, but it might be something worth picking up in there. Any questions? Send me a question. If I can help you, I will. All the best. Enjoy the video. The thing you've just seen at the beginning of the video, I don't know what it is yet because that's obviously the final product of what I've made. Anyhow, basically, I want to make a camera slider. I've already got a camera slider. This is a really nice simple one, just made from bits and pieces left over from CNC or 3D printer. And this is sort of slide stuff that you can buy on Amazon or anywhere else, and it's just a V-slot, and you add wheels, make bits and pieces, and everything just runs nice and smoothly. However, this is my little one that I sort of knocked together in no time, and it works. It does its thing. You start filming and you slide the camera along, and yeah, everything kind of looks okay at the end. But you can't move this smoothly no matter how hard you try. So I don't even know what this thing's going to look like yet. Anyhow, I'll get my ideas together and see what I can come up with. Let's get started and design something. So as in with this plate that I already made that slides up and down, it's a little bit flimsy, but you can buy sort of specially made ones which are about 3mm thick. So I'll buy one of those and change the wheels over. I've got plenty of Arduinos. So what I want to do is, if we imagine that's the rail, and then this piece has its little wheels, then we're going to need some sort of thing like a motor that holds something like that. So then you'll need another motor here and a motor there. So this motor will be the pan, so that should pan the actual camera around like so. And then this motor here will be a tilt, so that will tilt it up and down. And then we're going to need a motor on the end here for the rail. And I thought of using a screw thread all the way along it, but I want to buy a really long piece of 2040 V-slot rail. If I'm going to make this, I might as well make a big one. And then, of course, we're going to need a controller. So, I don't know, that end, this end, it doesn't matter. Some sort of box with maybe a joystick or something like that for the pan and tilt, and maybe a turny button to change the speed of this, and a button to stop or memorize it. Now there's a point, stop. Now when this thing switches on, I want to have some sort of relay so that it moves along to that relay, and then when that's activated it'll stop, and that will be 0 point, because in the Arduino you're going to be sort of calculating how many turns that one of these stepper motors is doing. Now all these stepper motors that I have, I've got plenty of them, they are 200 sets of signals, if you like, 200 points per revolution. So every time this does one revolution, you'll have to calculate sort of how far it's travelled, and that will be 200 steps. So somehow in the Arduino you've got to let it know that you've done 200, another 200, another 200, so far, well, and so on until you get to the end. And then that way, if you can make it so it goes up and down, you can start putting some clever magic into the programming of these Arduinos. And also, if you make it start where there's a switch that zeros its calculation, you can say this can only travel, say, 1000, and that's the end. That way this thing isn't going to go and run off the end of the track. Maybe also put one on the pan, because your wires, if you've got the pan going round and round, you're going to tangle the wires up. I don't think it'll matter with the tilt whether that goes round and round forever, because you'll have your camera on there, as long as your camera's got no wires going to it. If it's a battery operated camera, of course, then it doesn't matter how many times it's going to tilt. And as the wires are going to be on this piece, it's just this bit that you've got to be careful of how many turns it's going to do. So yeah, maybe put some sort of little switch in there as well. So we're going to have 4 wires there, 4 wires for that one, and 2 wires for a micro switch or something. Little micro switch, just so that when it passes a point, it again counts to 0. So we're going to need 10 wires going to there, another 4 wires going to here, another 2 wires going to that, all the controls and everything. I'm not sure if that's going to be able to handle it. I'm sure it will. Somehow we'll make it work. So I'm going to order a nice plate for this, and some more 2040 and some other bits and pieces, and I'll order them off Amazon. And I'm going to put in the bottom, hang on, which way is my finger pointing? That way. I'm going to put in the bottom, in the description, links to every piece that I buy and put towards this. So hopefully, you know, if you want to make something like this, that I'll have a list, and you just click on it and you'll find all these bits and pieces. Now, I'm buying all these bits and pieces myself, but if you do click on any of the links that goes to Amazon, I've got an affiliate, so I'll earn a tiny little bit back, which will help to go towards making more videos and things, hopefully. So that's just my little declaration there, is to say I do have an Amazon affiliate, and if you buy it from down there, I'll get a little bit back, and every little helps. Thank you. So I'm going to order the bits of Amazon, and I'll just do a little bit of homework. This is a brilliant little book to get you started with Arduinos. So I'll have a little bit of a read of this and wait for my order. So some of the pieces have arrived, and I've got some nice 2040 V-slot rail here. I bought 2 pieces of this. This is a 1 meter piece, but I also bought, just in case, a 1.5 meter. You see, I can't even get it in the camera, it's so long. If you're going to make something like this, you might as well make it nice and big. So yeah, this here is called a gantry, and it's 3mm thick. It's got lots of holes already cut in there, and a lot of the holes are in the right place, so you can do several combinations of putting the wheels so it'll fit on a 2060, which is 3 times this, or 2040 or whatever. And then of course you've got all holes in the center and things for putting well, the beginnings of what it is you're building. Now, because I bought a 1.5 meter rail as well, I've bought 5 meters of this band. Now this is 2mm pitch, and it's 6mm wide, and that runs on the motor, and then we'll attach it. And obviously you need about 3 meters to cover for a 1.5 meter rail. I've also bought some closed loop stuff because I had a bit of an idea. If I attach one of those on there and I have the piece of metal, I'm just looking for a piece of metal to show you, say this. So say this is the piece that's going to turn, then what I want to do is actually put the motor that way round, and this will attach to this, and this will be solid, so the motor will be driving the thing around like so. So I thought that would be better than having a motor underneath, because that would be lifting it up really high. So if I can make it so the motors and things are actually inside the piece that turns, it's going to give it a lower centre of gravity. It's going to make everything a bit more closer to that, rather than having a huge thing this high. So yeah, I'm still trying to figure out bits and pieces of what I'm doing. But like I say, all these bits are all going to be linked below, and hopefully somebody else is going to make one as well. So right, moving on. Oh, by the way, lots of little nuts and bolts and corners and things. I've probably bought things that I don't need, and these are quite handy, and I'll show you why. I had an idea. If I'm going to turn this, then this has got to be free to move. So that means I need a bar, and the bar will go through these, and that will attach, drill a hole through it, and they actually tighten up. They've got little grub screws on them, so I'll be able to tighten that to a bar, and it will be free to move. Hopefully. I don't know what I'm doing here. I'm just making it up as I'm going along, but bear with me, I'll get there. So the idea for the pan and tilt mechanism is there's a couple of pieces of aluminium here, and I'll bolt those two together, and this will be attached to this. Now, you don't need to find one of these. You can just get a piece of aluminium that's L-shaped, like so, and put a slot or a hole in it so that it will attach the camera to it. So hopefully this camera thing will be able to tilt like so, and the whole thing will turn like that, which is the pan, and that's the tilt. Now, these are 60 tooth wheels, and what I'll do, I'll screw through here onto there, so that is solidly connected to that. But to make it free to move, I'm going to put these bearings either side of that, drill a hole through, and I've bought some of this 8mm bar. The thing is, it's so tough, it's actually very difficult to saw through. I've been trying to saw this, and all I've done is sort of mark the surface. So I'll figure out a better way to cut through in a bit. Now, what happens is, these have little grub screws on. So you slide that onto where you want and then just tighten it up. So I'm going to have to cut a little piece like so and have one of these either side. I actually only bought one for that side and one for that side, and I think it's too much stress. It might sort of allow it to do this. So I want to actually put 2 of these there and 2 of them here, because this part will be connected to the bottom, and then this will have a bar going through there for the tilt. So hopefully the whole thing does that, and this whole bit will do that. Now, I'll put a motor inside there, and that will have a band like so. Just partially assemble it. I've been playing about with this several different ways, trying to come up with something. So then that motor will turn the tilt, and then this one, which will all be connected to kind of that, I'll have that motor there. I mean, there's wasted space there, so I might as well put a motor there. I'll just put it that way for now, because I can't get it to sit downwards. We'll put it that way. But actually it'll be like that. And then there'll be another band there, and then this piece will be connected to the rail. So the whole thing should pan and tilt. So I've come up with this kind of design. So this stepper motor is going to be for the rail, and this is going to be for the pan, and this one for the tilt. I've put these little stickers on so you can see more clearly what's happening with the motors. Here's the Arduino, And what I've done, I've put 3 of these easy steppers on. Now you can get these tiny little stepper motor controllers, or you can get these easy steppers. I know they're sort of more than twice the size, but I don't know, I kind of think maybe they'll have a bit more oomph to them. I really haven't got a clue. If I'd have bought 3 of these, I might have been able to make the whole circuit even smaller. But anyhow, so I've bought 3 of these. So the idea is, when you power up the Arduino, the first thing the device wants to do is to make the camera travel all the way to the left until it hits a micro switch. Now in this case, this blue button is my end switch, micro switch, okay? And this little micro switch is for the panning. That way you're not going to get your cables all tangled up, hopefully. So when you turn this on, in the program, the first thing it does is it'll send this to the left until it hits the micro switch. The next thing it should do is turn the actual pan until the little micro switch is activated on there. That's this one here, okay? And now what I have also is 3 potentiometers. Now these potentiometers should allow you to adjust and move and pan and tilt and set up on the rail exactly where you want the camera to start. And when you've set that up, you press the white button, and then you will use these 3 potentiometers again to move this all the way to the right, to pan the camera and to tilt it, and then press the button again. And that is going to set in the second set of coordinates. So you have A and B. I'll show you with the camera. So you set up, you do all this business, you say, right, you are A, press the button, you go all the way along, you pan and tilt, and you say B. And then the next press of that button, it should hopefully move, and then press it again and move, and it'll just keep on doing that. So it's only going to hold 2 sets of coordinates, the A and the B, the beginning and the end if you wish. But I don't know, I think that's going to be handy enough. What I've also added in here is, because even when you're not moving anything, because this has got 3 stepper motors on and 3 of these easy drivers, that takes up a lot of power. And if I'm going to make this work on a battery, I might want to set up A and set up B, do a filming, but then, so I don't lose them coordinates, I want to be able to switch off the stepper motors and things, because the Arduino will run on a very small amount of current, but these take up 10 times as much as the Arduino. So I've added another little switch here to deactivate the steppers. What can also be advantageous to that is, if you deactivate the stepper, you can move by hand a little bit of, I don't know, a little bit of the rail or a little bit of the tilt or something, and that doesn't get recalculated in the Uno. So when you switch it back on again, it'll start from that position. Anyhow, let me show you how this works. There's also another potentiometer here, and what that does, that's going to be the overall speed. So if you set it from A to B and it does this nice and quickly, and you think, oh no, it's too fast, rather than start setting in all these coordinates again, you just turn the speed up or turn the speed down or whatever, and it'll do the same thing but much, much slower. Now I'll fire this up and I'll show you what it does. Turn on the power, and the first thing should be the rail. So now that's going to go all the way to the end until it meets its micro switch. Now when it does that, the pan turns until it meets its micro switch. And what I've also done there is, where it meets its micro switch, I've told it to go back so many steps. The reason being, when your pan goes all the way around and hits its micro switch, you want it to sort of level back up again. So I can add another instruction that says turn and face that way or whatever. I don't know if it's going to be correct yet. I'll mess about with the coding once I've constructed it all. So moving on, you see the little blue light has come on there. It looks white on this video camera, to me anyway, but that's actually blue. So now what we can do is it's waiting for me to set up its beginning point wherever I want it to be. So I can turn, say that's about there. This is doing this sliding, okay? And maybe I want the pan to be facing to the right, like so. You see, you've got speed control as well. The more you turn it, the faster it actually goes. Very slowly or much quicker. So you'll have a bit of control on there. And also in the instructions in the Uno, I've made it so these motors move much more slower than the actual rail. So that's your pan. This is going to be your tilt. Let's say you just want it there. Okay, no, actually, just for this video, I'll make them line up because I think it'd be interesting to see if they actually go back to that point. Right, so this is the starting point. Now, when we've done the starting point, you press the little button and this will turn red. There you go, it's turned red. So this first set of coordinates are now in the Uno. Okay, it's set everything to 0. So now it's allowing me to say, right, I want the 1, 2, 3, 4, 5. Right. So that has moved this along that much, say. But then I also want the pan to move all the way to the left. Okay. And I want it to tilt up just slightly. Okay, about there. Very nice. So I've told it to go along, I've told it to pan the camera to the left and tilt up very slightly. So now it's waiting for me to press that little button. As soon as I press that button, those counts will be loaded into the Uno. So if I press it again, that goes green, which means, hey, we're good to go. Brilliant. Now, this button here, like I said, is the speed of the overall thing, and it will calculate so that everything starts and ends together, hopefully, depending on what speed I turn this. Now, when I press that button again, then it'll say, right, move back to that position. If I press it again, it'll say move back to that position. And it's just going to do that backwards and forwards all the time until I reset it. But it'll read this once. It'll only read it when I press that. It reads where this potentiometer is, and then it'll get on with its thing. So it doesn't matter if I nudge this or anything, it's not going to change its speed until it's completed its task. So let's have a look. There we go, it's panning to the right, the rail's taking it back to the left and it's tilting downwards again. And that white and blue should meet up. There you go. So that's now moved it from B back to A again. If I press it again, it'll do the whole thing again, and it's moving from A and going all the way back to B. Any moment now. Thank you. Now then, I can change the speed and make it go much quicker. You can hear the motors are a little bit louder. I can change something in the code so it goes even faster than that, but if you go too fast with the stepper motor, you risk it skipping steps, and you don't really want it to skip steps if you want it to accurately do something backwards and forwards. So this will go down really slowly, but I'm not going to press it there because I've already tried this and it just takes like 5 minutes to go from there to there, and this video is already going to be too long. Now then, what I've added in here as well, like I say, is this little switch here, and what this switch will do is it will disable these, because at the moment this is taking 560 milliamps just sitting there because it's holding these. There's a bit of torque here and that's taking up a lot of current. So if I want to sit it to one side before I do a bit more filming, but I don't want to lose those coordinates that are in here, I can just flick that button and these three have now switched off. The little red light there is just to tell me the stepper motors are not activated. And I can't press that button. That's disabled as well because you don't want the Uno will do its business and it will count back again not realizing that the stepper motors aren't moving. So that's got to be disabled as well. So the whole thing is disabled. It's just sitting and waiting for me to switch that back on. Now when it's switched back on again, we can just carry on and do another filming shot. I found one of these LED power supplies which was broken, so I stripped everything out, and this is what you're left with, a nice sort of long aluminium box like that, which means I'll be able to actually get the rail so it screws onto it. So this is going to be permanently connected to the actual rail with screws, and then all the sort of electronics and the Arduino and everything should be able to go inside there. What I've come up with is just a board to put all the switches on, and that gives me an idea of how much room I've got in here to play with. So yeah, that and that makes that sort of thickness, and then the whole lot will sit in there just nicely. And I'm sure you'll be able to find a metal container that'll do the job for you. You might find a better one than this. I was just being mean and using what I've got. All the designs for the circuit board and everything else that I come up with will all be on my website, and there'll all be links below. And like I say, links for everything that you can buy is going to be underneath the video. I'm going to cut the holes out for the potentiometers and the switches and everything here, and then put that in from underneath like so. Right, so far so good. Everything's in the case now, and it's a little bit of a tight squeeze. I don't think I can get anything else in there. But what I've also done is I've added a little tiny push button here. Now that is just about the right height, I hope, so that as the rail piece comes along, it just touches it and switches it. So hopefully that will be like the end stop. I've kind of built it in there because it looks nicer. So I haven't kind of got around to hiding these cables down that little shaft there at the moment. I'm still thinking about drilling a hole through there or getting an 8mm tube and maybe threading the wires through to the bottom. But temporarily, I've got the wires all set up here. I've put the actual motor drivers onto this big chunky heatsink on the back here. So that should help. And it might help give a little bit more balance to this thing, hopefully. So anyhow, let's see if it works first. It should do. Yep, it's all lit up, little red lights on there. It's this motor here is what would be pulling this along until it gets to the stop, which is there. And then once it's reached that, it'll try and level up the camera. And I'm going to trigger it with this one. Okay, so now the blue lights come on, so it's all ready to do whatever you wish. So you can have sort of manual control anyway. You don't have to set in any destinations, and you can turn it left and right and things. So I've made the little remote switch here, and that's just an old sort of reversing camera, and it wasn't any good. It was broken. I couldn't fix it, so I thought I'd use the case, and it makes a nice little handy thing to hold with a push button in the top. So just press the button and off it goes. That way you can go and stand a long way back, and operate it with either a foot switch or another switch or something. You don't have to be pressing this button on the end here all the time. And I've made the legs. The legs sort of turned out okay. This is nice and solid. And you take the legs off, and what's left behind are some UNC quarter 20 threads, which is a standard type of camera fitting thread. So now I've got a place where I can attach 2 tripods to it and have it at different angles, or just place these feet on it and it sits on the desk nice and solidly. So I'm going to do a few little example bits of video now. All the code to this will be on my website, or I'll put a link to it underneath the actual description there. I've managed to set up the sort of rail direction now. I've corrected that. That was a little bit of a brain ache, but I've figured it out, and I've changed some of the speeds. So now let's take that out. So now if I turn it on, it should go through all its initial kind of setups. And this is so that it knows where the 0 position is of all the motors and things, except for the actual pan. The pan can go round and round forever. It's not going to tangle any cables up anyway. So it comes back, the panning goes and faces forward. So those numbers now are actually in the Arduino. I've also set a limit in numbers to the end of the rail here. If you try and go any further, then I think it's about 40,000 steps of this motor. If you go any further, it just stops, so it's not going to try and run off the end or rip its belt to pieces or something. So yeah, as long as it reads this micro switch, this end, that's 0, and this end is about 40,000 steps of that motor. So you can't go any further than that. So right, I'll just do a couple of little kind of demo-y bits of video of scooping over things, see how smooth it is. Yeah, that will obviously be the bit maybe that you see at the beginning of the video, which introduces this video that I haven't filmed yet. I'm going to film now, so it's going on the beginning. Yeah, you get the idea. So yeah, there you go. Nice little project, and hopefully I'll be able to use it for all my bits and pieces, bits of filming. Yeah, I could have used a smaller one, but you know, I fix keyboards and synthesizers mainly on my channel, so I needed something much longer that can go, you know, for quite a distance, rather than something that's only 30 centimeters or whatever. This is 150 centimeters. The whole unit is over 1.5 meters long, and that gives me plenty of plenty of scope for doing things, hopefully. Anyway, thanks so much for watching, and all the best. Bye bye. It's all very nice having a remote control on a bit of a cable and plugging it in there and controlling it with a cable, but what would be really nice is if I could actually operate it with a mobile phone, and I can. Watch this. You don't even need an app. You just, there you go. Controlled by mobile phone. Huh? See?